Hello, my dear students. My name is Lakshmi Narayana. This is Ellen brand of chemistry. Today we are going to discuss geometrical isomerism. So, see, once before going to the geometrical isomerism, what is the classification of isomerism first? Sir, previous what isomers we are discussing in the isomerism topic. Sir, isomerism generally classified into two categories. One is structural isomerism, then one more stereoisomerism. So structural isomerism already done, it is completed in the previous lecture. So this is actually lecture number 6. Sir, isomerism topic, lecture number 6 we are going to discuss. So the previous that is sir, lecture number 1, 2, 3, 4 and as well as 5 up to there we are discussing about the isomerism, previous structural isomerisms. So now we are going to discuss about the stereoisomerism. The stereoisomerism again divided into two categories. One is configurational isomerism. One more, conformational isomerism. In the configurational isomerism, again they are divided into two categories. Sir, what are those? Sir, one is geometrical isomerism. Then optical isomerism. So geometrical isomerism, in this geometrical isomerism, three categories are there. One is cis-trans isomerism. Number 2, EZ isomerism. Number 3, Syn-Anti isomerism. So this is in the geometrical isomerism. Then in the optical isomerism, again these are divided into two categories. One is enantiomers, diastereomers. See, in the configurational isomerism, actually configurational isomerism means we cannot separate these isomers. We can separate these isomers. Separate these isomers by using chemical methods, by using some methods. But conformational isomers we cannot separate by using either physical methods or chemical methods. So these are cannot separate. These can be separate, which are configurational isomers can be separate. Under the configurational isomers, geometrical and optical isomers are there. Geometrical isomers again divided into what are cis-trans isomerism and EZ isomerism and Syn-Anti isomerism. This is we are going to discuss now, geometrical isomerism. Yes. So today topic is geometrical isomerism. In the geometrical isomerism, what is cis-trans isomerism? What is EZ isomerism? What is Syn and Anti isomerism? Which type of compounds are exhibit geometrical isomerism? That we are going to discuss. So which is geometrical isomerism? So to exhibit geometrical isomerism, some conditions are there. What are those conditions we have to discuss now? Sir, one is first condition. Sir, here as a carbon, in between the carbon, restricted rotation should be present. So restricted rotation means in between the carbon, in case single bond is there, that we call free rotation. Just assume it is one of the carbon, కార్బన్ కి మధ్యలో సింగిల్ బాండ్ ఉంటే ఫ్రీ రొటేషన్ జరుగుతూ ఉంది, ఫ్రీ రొటేషన్ ఇక్కడ. సరే అలా కాకుండా కార్బన్ ఇన్ బిట్వీన్ కార్బన్, ఇన్ కేస్ డబుల్ బాండ్ ఇస్ దేర్ లైక్ దిస్, sir, it cannot freely rotate. That we call restricted rotation. What we call restricted rotation. So in this also, to exhibit the geometrical isomerism, compound must be follow. One is compound must be restricted rotation. Sir, where restricted rotation will be present? Ekkada restricted rotation? Sir, in between the carbon double bond is there, then restricted rotation will be present. Even in between the nitrogen double bond is there, also restricted rotation is present. Then even in between the carbon and oxygen double bond, also restricted rotation will be there. And also, sir, in between the carbon, in case single bond is there, restricted rotation is possible? No, free rotation, now I told you. Sir, when single bond only is there, free rotation will be present. But in case if you take the cyclic compound like this, sir, carbon, even in the cyclic compounds also, restricted rotation is possible. That's what, sir, here in these compounds, restricted rotation possible. Okay, right. Then second condition, different atoms are attached to each carbon atom, or each double bonded atom. Sir, here for example, C double bond C is there. So each carbon attached to different atoms. Different atoms are attached to each carbon atom, right? Even here also, A, B must be attached to different carbon atoms. So in between carbon, sir, in case A, two same atoms are there, so does not exhibit the geometrical isomerism. Adi geometrical isomerism exhibit cheyadu. Sir, which type of compounds can exhibit? Sir, carbon double bond carbon. Then this must be attached to our different atoms. So such type of compounds can exhibit geometrical isomerism. Then third one more, that is all atoms are present in one plane. All atoms are present in one plane. Sir, for example, this is double bonded carbon atom, that is sp2 hybridized carbon. Even it is also sp2 hybridized carbon. So sp2 hybridized nothing but trigonal planar. Even here also trigonal planar. So all the atoms are present in one plane, right? So like that, all the atoms should be present in one plane. Sir, A, B and as well as C. Then A, B and as well as carbon. So all these are present in one plane. Then we call all atoms are present in one plane, we call, right? So to exhibit the geometrical isomerism, these conditions are must. Sir, what are those conditions? Compound must be restricted rotation. Then second, so different atoms are attached to the same carbon atom. Next, third, all atoms are present in one plane. Okay. Then before going to discussion about all the compounds, sir, here one of the point you have to understand, that is geometrical isomerism means molecular formula is same, molecular formula is same, and a structural formula also same. Molecular formula same, structural formula also same, structural formula same, but different spatial arrangement of atom. Different spatial arrangement of atoms. That is called geometrical isomerism. Geometrical isomerism means what? Molecular formula is same. Molecular formula is same. Structure formula also same, but different in the spatial arrangement of atoms. For example, one of the compound is there like this. One of the compound is there. Sir, just assume it this one of the atom. This is a central atom surrounded by atoms. These are. Sir, అన్నీ కూడా ఒకే ప్లేన్లో ఉన్నాయి. ఒకే ప్లేన్లో ఉన్నాయి. So, spatial arrangement of atoms in case if it is differ like this. With the previous molecule. With the previous molecule is this, then this. So, now both are having the same molecular formula, same structural formula, but spatial arrangement of atom is differ. Then we call it is geometrical isomerism. So, in the to exhibit the geometrical isomerism, what I told, to exhibit the geometrical isomerism, then compound must be restricted rotation. Then next, different atoms are attached to the each carbon atom. Next, all atoms are present in one plane. That we have to see which type of compounds can exhibit geometrical isomerism. Which type of compounds can exhibit geometrical isomerism? So remember, what are the conditions? Conditions, one is restricted rotation should be present. Then next, restricted rotation should be present. Next, so each carbon atom different groups should be present. Then next, all are should be present in one plane. So example number 1 we are taking. Example number 1, that is C double bond C, then sir CH3, then Cl, then Cl, then CH3, like this will be there. Sir, is that exhibit geometrical isomerism? This geometrical isomerism no exhibit chesta unda. Is that exhibit geometrical isomerism? Yes, it can exhibit geometrical isomerism, right? Why? What are the conditions is following or not? Yes. What are those conditions? In between the carbon double bond is there, so that's what is the restricted rotation. Each carbon atom, two different atoms should be present. Yes, that is also possible. Then all are present in one plane because of sp2 hybridization, right? Then one more, second one, look at C double bond N, then here lone pair of electrons are there. Sir, OH is there, then H is there, then CH3 is there. Sir, is that exhibit geometrical isomerism? Yes, geometrical isomerism is exhibit. Sir, why? What is the reason? Restricted rotation is there. Sir, all are present in one plane. So look at two different atoms here, electron density is there, then as well as here OH, then CH3, then H. So geometrical isomerism it can exhibit. Then third one, sir, C double bond C, then here CH3 is there, then C2H5 is there. CH3 is there, then C2H5 is there. Two different atoms or not? Yes, two different group of atoms, right? So here, then H is there, then H is there. Is that exhibit geometrical isomerism? No, it won't exhibit. So each carbon atom must be two different groups or two different atoms. So here two different atoms, okay, but here the same atoms are present. So it won't exhibit. No, it won't exhibit. But sir, in case here any one of the atom, when it is replaced like CH3 or any other atoms, then it can exhibit. Yes, it can exhibit. Then fourth one, so look at C double bond C, then Cl is there, sir, F is there, sir, Br is there, then H is there. Is that exhibit geometrical isomerism? So no doubt at all exhibit geometrical isomerism. Even this is also exhibit geometrical isomerism. Even this is also exhibit geometrical isomerism. Reason is what? So restricted rotation is there. Each carbon atom attached to different group of atoms, two different atoms. Even here also two different atoms. So it can exhibit. Next, sir, C double bond C, then CH3, then bond CH3, then Cl bond H, like this will be there. Is that exhibit geometrical isomerism? Yes or no? No. Why no? Because two same atoms or same group of atoms are attached to the carbon atom. ఈ రూల్స్ ఫాలో అవ్వట్లేదు. జామెట్రికల్ ఐసోమెరిజం కు ఎగ్జిబిట్ చేయాల్సిన కండిషన్స్ ఏవైతే 3 ఉన్నాయో అందులో సార్ ఒకటి డబుల్ బాండ్ ఉంది, ఓకే, రెస్ట్రిక్టెడ్ రొటేషన్ ఇస్ దేర్, దెన్ ఈచ్ కార్బన్ ఆటమ్ మస్ట్ బి అటాచ్డ్ టు టూ డిఫరెంట్ గ్రూప్స్. సో ఇది టూ డిఫరెంట్ గ్రూప్స్ లేదు, సేమ్ గ్రూప్స్ ఉన్నది, సో ఎగ్జిబిట్ చేయట్లేదు. దెన్ సి డబుల్ బాండ్ సి, దెన్ హెచ్, సార్ హెచ్, దెన్ CH3, దెన్ C2H5, like this will be there. Sir, is that exhibit geometrical isomerism? No, because the same atom will be present. So no, it won't exhibit geometrical isomerism. So then one more, C double bond C, then in between one is H, sir, one is CH3, one is Cl, then one is Cl, like this will be there. Sir, is that exhibit geometrical isomerism? No, it won't exhibit geometrical isomerism. Why? What is the reason? The same atom, same kind of atoms are attached to the carbon. సేమ్ ఆటమ్స్, సేమ్ కార్బన్ ఆటమ్స్ ఈ కాంపౌండ్కి ఒకే కార్బన్ ఆటమ్కి అటాచ్ అయ్యాయి. సో దట్స్ వాట్ రూల్స్ ఆర్ నాట్ ఫాలోయింగ్, దీస్ ఆర్ నాట్ ఎగ్జిబిట్ ద geometrical isomerism. Clear all of you? Right. So now we are seeing which are exhibit the geometrical isomerism, which are not exhibit the geometrical isomerism. Sir, one more compound I will tell to you, one more compound. Sir, in case sir compound is there like this. Sir, here H is there, here Cl is there. Then here Cl is there, here H is there. Is that exhibit geometrical isomerism? So, and each carbon atom two different groups ఉన్నాయి, two different groups ఉన్నాయి. Is geometrical isomerism exhibit చేస్తుందా? No, never. Why? Sir, in between the two carbon atoms, restricted rotation should be present. So, restricted rotation లేదు, single bond ఉంది అంటే, then free rotation ఉంది. So, free rotation ఉంటే does not exhibit. Sir, when restricted rotation is there, then exhibit, yes. Yes, that can exhibit geometrical isomerism. Understand, my dear students? Right. So now, first in the geometrical isomerism, we have to discuss about the cis-trans isomerism. What is the cis-trans isomerism? Sir, which type of compounds can exhibit cis-trans isomerism? That we have to see. That we have to see. Sir, first cis-isomerism. Cis-isomer means what? Cis-isomer means identical atoms or group of group of atoms are attached to same side of carbon atom. Same side of carbon atom. For example, carbon atoms, C double bond C. Identical groups. For example, sir, A. So double bonded carbon atoms ki same side identical groups attach ayi unte, then we call it as cis-isomer. దీన్నే మనం cis-isomer అంటున్నాం. Like this. At least one identical group should be present. Then second one, trans-isomerism. Trans-isomer. Identical groups, identical atoms or groups attached to opposite side of double bond, C double bond C. So look at identical groups, sorry, A, then B, like this. Identical groups opposite side unte, then we call it is then trans isomer. That we are calling cis trans isomerism. So which type of compounds can exhibit the cis trans isomerism? Sir, I told that cis isomerism nothing but identical groups are attached to same side. Then trans isomer nothing but identical groups are attached to opposite side. Then we are calling cis isomer and trans isomers. Sir, what I told, cis isomer means identical groups same side should be attached, same side. Trans isomer means identical groups opposite side. Clear? Sir, for example number 1, sir, C double bond C, right? Then CH3, then CH3, then H, like this. Identical groups attached to the same side of the double bond or not? Yes, same side of the double bond. Then we call it as cis isomer. Cis isomer, cis 2-butene we call. Cis 2-butene. Sir, why 2-butene we are calling? Sir, carbon number 1, 2, 3, 4 numbering we have to give like this. At the second place, double bond is there. So this is this restricted rotation wherever the geometrical center is there, wherever the to exhibit the geometrical center is there, that is cis isomer. So that's next, C double bond C is there. Then H, CH3, then CH3. We'll see, then identical groups are opposite side will be there. Either CH3 if you take or H if you take, identical groups are opposite side. Then we call it as a trans isomer. Then one more, C double bond C. Then Cl in case if you take. Then CH3, then CH3 if you take. Identical groups, either CH3 or Cl. Identical groups ఏదైనా తీసుకోండి, ఐడెంటికల్ గ్రూప్స్ ఇవి రెండైనా తీసుకోండి లేదా ఇవి రెండైనా తీసుకోండి, ఆపోజిట్ సైడ్లో ఉన్నాయి అంటే ట్రాన్స్ ఐసోమర్. Then here C double bond C, then Cl, CH3, then CH3. Then we call it as cis isomer. Then one more, sir, cinnamaldehyde, cinnamic acid, which is the cinnamic acid C6H5, CH double bond CH bond COOH. We call it as alpha beta unsaturated carboxylic acid, cinnamic acid. So look at C double bond C, then one side COOH group, then one side phenyl group is there like this, phenyl group. Sir, H, then H, like this will be there. Identical groups here we have to consider as this, identical groups away from each other. Then we call it as a trans isomer. Then same, C double bond C, H, then COOH, then phenyl group is attached, then cis isomer. We call it as cis isomer because identical groups are same side will be there. So identical groups same side unte cis isomer ani, identical groups opposite side lo unte trans isomer. So identical groups same side lo unte cis isomer ani, identical groups opposite side lo opposite direction lo unte, then we call it as trans isomer like this. See, so these all are, we can identify what is cis, what is trans because identical groups will be there. So identical groups is there, then we can exhibit, we can say that it is geometrical isomer. Sir, which type of questions they are asking in the NEET examination or JEE mains examination? Which of the following alkene can exhibit geometrical isomerism like this? Which does not exhibit geometrical isomerism? Such type of compounds also they are asking. See, look at, sir, question number 1. Which does not exhibit geometrical isomerism? Does not exhibit geometrical isomerism. So compound A, CH2 double bond CH bond C double bond CH double bond, then bond CH bond CH3. Is that exhibit geometrical isomerism or not? Then B, C double bond N CH3 bond H, then lone pair of electrons are there, OH will be there. Then C double bond O, then H, CH3 is there. Then D, C double bond C, CH3 bond H, then CH3 bond H like this, which does not exhibit the geometrical isomerism. They are asking question. Sir, here at this center, actually two centers are there to exhibit the geometrical isomerism. Two centers are there. At this center does not exhibit the geometrical isomerism because the same carbon atom attached to the same kind of groups. Then if you come to there, sir, it can exhibit C double bond C first, then identical groups you have to consider as H, then CH3, then the remaining group whatever it is there, that is CH, then double bond CH2 like this. So this cis isomer avutundi, then opposite trans isomer, opposite direction. Even this is also double bond restricted rotation, then HOH consider as, so same side will be there. So it can exhibit or not? Yes, it can exhibit. Here it cannot exhibit the geometrical isomerism because both sides electron density will be there. Oxygen attached, here lone pair and here lone pair, the same kind of atoms, you have to consider as same kind of atom. So do not exhibit geometrical isomerism. Geometrical isomerism exhibit cheyadu. Understand, my dear students? So such type of questions they are asking, which can exhibit, which cannot exhibit, you have to understand. Okay, right. Sir, which can exhibit the geometrical isomerism, which cannot exhibit the geometrical isomerism? Such type of questions they are asking. See, in the cis-trans isomerism, sir, one more important compound, that is C double bond C. Sir, COOH, then COOH, H, then H, like this will be there. That is we call malic acid. Malic acid. So this is cis isomer because identical groups, that is COOH are HH. One side of the double bond will be there, that's what. Then C double bond C, sir, COOH, then COOH, H, H, identical groups away from each other. Then this we are calling actually fumaric acid. Fumaric acid. So this is transform. They will ask a question based on this. Sir, dicarboxylic acid, alkane dicarboxylic acid, that is fumaric acid. Fumaric acid is a cis isomer or trans isomer, they will ask. It's a trans isomer, you have to remember. Fumaric acid, COOH groups are away from each other. Then here, same side of the double bond, it will be attached. So these are cis-trans isomerism. So in the cis-trans isomerism, we can observe that in case each carbon atom having the same kind of atoms, it cannot exhibit. Different kind of atoms, it can exhibit the geometrical isomerism. But carbon in between carbon, restricted rotation should be present. Then all the atoms should be present in the planar. So here, a new kind of geometrical isomerism, we can observe that. So that is, sir, in case in between the carbon restricted rotation is there, but here, sir, H is attached, then Cl will be attached. Then here Br is attached, then iodine is attached there. There is no identical atom, identical group. So at that time, we have to call it is Z isomer, then E nothing but E isomer. Sir, here remember Z isomer is equivalent to cis isomer. E isomer, it is equivalent to trans isomer. So how can you identify which is cis, which is trans? Nothing but which is Z, which is E. This is identified based on the priority order. What is the priority order? Sir, here in case carbon double bond carbon, sir, here it is attached. Then higher priority of the atom or group of atom, lower priority atom or group of atom, then higher priority, then lower priority, like this will be present. Once same priority, higher priority of the groups are same side will be there, then we call it as a cis, nothing but Z isomer. Sir, in case lower priority or higher priority, opposite side will be there. Higher priority, then higher priority, low priority, then low priority, like this. Then we call it as E isomer. Sir, ఈ priority order ని ఎలా ఫైండ్ అవుట్ చేస్తాం? సరే, ఈ ఆటమ్స్ కి రెండు కార్బన్, ఒక కార్బన్ అటాచ్ అయిన టూ డిఫరెంట్ ఆటమ్స్ కి ప్రియారిటీ ఆర్డర్ ని ఇవ్వాలి. అది ఎలా డిఫైన్ చేస్తాం? సార్, ప్రియారిటీ ఆర్డర్ ఇవ్వడానికి మనకు సిఐపి రూల్స్, చాన్ ఇన్ గోల్డ్ ప్రలాగ్ సిఐపి రూల్స్ ఆర్ దేర్. That rules, based on that rules we can say which is cis isomer or which is Z isomer, which is E isomer, we can say. So we'll see that. So now new type of isomerism, not cis trans, it is EZ isomerism. What is the EZ isomerism? EZ isomerism. Sir, E nothing but it is almost equals to trans. Z nothing but cis type, cis isomer. Okay, clear all of you, right? Sir, here according to priority will be given. Priority will be given according to CIP rules. Chan, Ingold, Prelog. These three scientists, they are given rules. This is we are calling sequence rules also. Sequence rules. Sequence rules. Sir, what are the CIP rules? What are the CIP rules? So rule number one. Rule number one. What is? Rule number one is priority. Priority will be given according to atomic number. According to atomic number. Higher atomic number. Higher atomic number containing atom, higher priority. Higher priority. Priority. So lower atomic number. Lower atomic number. Low priority. Low priority. Clear all of you? So look at, observe it carefully. Sir, in case bromine is there, iodine is there, then bromine is there, then chlorine is there, then fluorine is there. Sir, according to the atomic number, iodine is the most atomic number, then after bromine, then chlorine, then iodine. Sir, in case a group of atoms are there, for example, then OH, sir, then NH2, then CH3, then like this will be there attached to the atom. Sir, O is the first atom, then nitrogen is the first atom, next carbon here. Sir, here according to atomic number of oxygen is 8, then nitrogen 7, then carbon 6. So this is the priority order for that. Sir, observe it, my dear students, very clearly. Sir, what I told, in between the carbon, double bond is there, restricted rotation should be present. Then in case here chlorine and bromine is attached to there. Then one more, sir, NH2 is there, then OH will be present. NH2 is present, then OH will be present. How to give the priority order? Sir, bromine and chlorine, which is the highest atomic number? Of course, bromine is the highest atomic number, higher priority you have to take. Higher priority. Then here, this is the low priority, right? Low priority. Then in case if you take both, sir, oxygen, nitrogen, first atom you have to observe, oxygen and nitrogen will be there. Sir, which is the high atomic number? Oxygen is the higher atomic number, right? Atomic number for oxygen is 8. So higher priority. Higher priority opposite side will be present. When higher priority opposite side will be present, then what I told, it is E isomer. E isomer. The same compound in case C double bond C, then Br is there, Cl is there, then OH is there, then NH2 is there. So we know that oxygen and nitrogen, if you take, oxygen is the higher atomic number, higher priority. Then chlorine and bromine, if you take, bromine is the higher atomic number, higher priority. Then same higher priority of the groups are present same side of the double bond, then we call it as a Z isomer. So EZ isomer we call. Understand, my dear students? So this is the first rule only. First rule. Sir, what is the first rule? Rule number 1. The priority will be given according to the atomic number. Higher atomic number, higher is the priority. Lower atomic number, lower is the priority. Sir, second rule, we have to see the second rule and some examples based on that. Second rule. Sir, in case atomic number is same. Atomic number is same. So note that Rule 2. If atomic number is same, if atomic number is same, priority will be given. Priority will be given. Priority will be given according to atomic mass. According to atomic mass. Again, higher atomic mass, high priority. Lower atomic mass of element, lower atomic mass of the element, low priority. That you have to consider. For example, hydrogen, protium, hydrogen, deuterium, hydrogen, tritium will be there. So దీన్ని డ్యూటీరియం అంటాం, దీన్ని ట్రిటియం అంటాం. Sir, atomic number is same. These are isotopes we call. Atomic number is same. Mass is different. Mass is different. Sir, where the mass number is greater, that is the higher priority. Then for example, sir, one more. Sir, OH, then OH will be attached like this. Sir, here O16 is there. Sir, O18 is there. Sir, which is the highest atomic mass? Oxygen. Then one more. CH3 is there. Of course, even here also CH3 is there. Carbon 12 here, carbon 14 isotope will be there. Sir, mass which is more? Carbon 14 isotope is more. So, atomic mass is greater. Where atomic mass is greater, that is the higher priority. For example, my dear students, look at C double bond C will be there. Then here H, then D nothing but deuterium. Sir, what is that? Deuterium. So then CH3 12, then CH3, the carbon 14 this is. Sir, we know that higher atomic mass is the higher priority. So lower atomic mass is the lower priority. Then here higher atomic mass is the higher priority. Lower atomic mass is the lower priority. So higher atomic mass opposite side lo unte, then we call it is E isomer. E isomer. The same compound Z isomer, how can you write? So D will be there, H, then here C14H3, C12H3, then higher atomic mass, higher priority, then higher atomic mass, higher priority. Higher atomic mass of the elements are same side of the double bond is there, then we call it is Z isomer. Z isomer. So this is rule number 2. First rule number 1, atomic number, higher atomic number, higher priority, lower atomic number, lower priority. Second rule, in case atomic number is same, according to atomic mass we have to give the priority. Sir, higher atomic mass, higher priority, lower atomic mass, lower priority. Next rule number 3, my dear students. So rule number 3. So we have to see a rule number 3. According to CIP rules, rule number 3 we are seeing. Sir, what is the rule number 3? In case if same atoms are attached to the carbon, sir, go for the next atomic number. Sir, what I told, if same atoms are attached to, if atomic number or mass number both are same, if atomic number or mass number, if atomic number or mass number are same, priority will be given. Priority will be given priority will be given according to next atom atomic number. Next atom atomic number. For example, sir, here my dear students, in the third rule you have to understand carefully. Sir, a carbon atom is attached to that. A carbon atom CH, then Cl, then Br, CH, Br, then CH3, like this will be there, my dear student. Sir, you have to take the first carbon atom are the same, then next atoms you have to take. When we are going to next atoms, you have to note it according to the higher atomic mass, higher atomic number. So take it as first bromine is the higher atomic number, then after carbon, then after hydrogen. Sir, what's that? Sir, ఈ కార్బన్ కి నెక్స్ట్ ఏమేమి అటాచ్ అయి ఉన్నాయి? సర్, ఒకటి హైడ్రోజన్ అటాచ్ అయింది, నెక్స్ట్ బ్రోమిన్ అటాచ్ అయింది, నెక్స్ట్ కార్బన్ అటాచ్ అయింది. అఫ్ కోర్స్ దీనికి రిమైనింగ్ 3 హైడ్రోజన్ ఆటమ్స్ అటాచ్ అయినాయి. దాని ఈ కార్బన్ కి ఏం అటాచ్ అయినాయి చూసుకోవాలి. బ్రోమిన్ అటాచ్ అయింది, కార్బన్ అటాచ్ అయింది, హైడ్రోజన్ అటాచ్ అయింది. ఈ 3 ఆటమ్స్ ని, ఈ 3 ఆటమ్స్ ని సర్ అకార్డింగ్ టు అటామిక్ మాస్ యూ హ్యావ్ టు రైట్ ఫస్ట్. So look at, in case a carbon atom, for example, CHCl, then CH3, then CH2, then CH3 will be attached. అంటే డబుల్ బాండెడ్ కార్బన్ ఆటమ్స్ కి ఒకటి CHCl, CH3 is attached, then one more CH2, CH3 is attached. Like this will be attached. Observe it carefully. So దీని గురించి మాట్లాడుకుందాం ఫస్ట్. Observe it carefully. సార్ నేను ఏమంటున్నానంటే, సార్ ఫస్ట్ ఆటమ్ ఇన్ కేస్ ఇఫ్ యూ టేక్ కార్బన్, సేమ్ ఆటమ్స్ అంటే, సో యూ హ్యావ్ టు గో ఫర్ ద నెక్స్ట్ ఆటమ్స్. ఇఫ్ అటామిక్ నంబర్ ఆర్ మాస్ నంబర్స్ ఆర్ సేమ్, కార్బన్ అటామిక్ నంబర్ is same, mass number is same, then priority will be given according to the next atomic number, next atom atomic number. So look at, that's what I told. ఈ కార్బన్ ఎన్ని ఆటమ్స్ అటాచ్ అయింది? సర్ లుక్ ఎట్ ఈ కార్బన్ H అటాచ్ అయింది, క్లోరిన్ అటాచ్ అయింది, C అటాచ్ అయింది. సో అకార్డింగ్ టు మాస్ అటామిక్ నంబర్, సర్ క్లోరిన్ విల్ కమ్ ఫస్ట్, దెన్ కార్బన్, దెన్ హైడ్రోజన్. ఇక్కడ సర్ కార్బన్, హైడ్రోజన్. సరే, ఈ ఆర్డర్ ఎలా రాయమంటున్నానంటే, అటామిక్ నంబర్ ఏదైతే ఫస్ట్ వస్తుందో ఆ ఆటం రాయండి, తర్వాత తక్కువ వచ్చే ఆటమ్స్. సో క్లోరిన్, నెక్స్ట్ ఆటం ఏమున్నది? క్లోరిన్ ఉన్నది. నెక్స్ట్ ఆటం కార్బన్ ఉన్నది. ఇక్కడ సార్ క్లోరిన్ ఉన్నది, దెన్ కార్బన్ ఉన్నది. సార్ విచ్ ఈస్ ద హయ్యర్ అటామిక్ మాస్? ఆఫ్ కోర్స్ దిస్ ఈస్ ద హయ్యర్ అటామిక్ మాస్. యూ హ్యావ్ టు గివ్ ద ప్రియారిటీ ఫర్ దిస్. అండర్స్టాండ్ మై డియర్ స్టూడెంట్? సార్ example number 2, look at. Example number 2, look at. I will explain one more example to you. It's very important. Sir, CHF is there. CHF. Then CH3 will be present. Then one more CH2. C, Br. 3 bromines are attached. ఎప్పుడు సార్ డబుల్ బాండెడ్ కార్బన్ కి ఇలా 2 డిఫరెంట్ గ్రూప్స్ అటాచ్ అయినప్పుడు, సార్ వన్ ఈస్ CHF, CH3 is attached, one more CH2, CBr3 is attached, like this. 3 groups attached. So first you have to observe the first atom, carbon, same atomic number. Then next atoms you have to go. So next atoms ఏమేమి అటాచ్ అయినాయో, సార్ ఒకటి కార్బన్ కి హైడ్రోజన్ అటాచ్ అయింది, ఫ్లోరిన్ అటాచ్ అయింది, కార్బన్ అటాచ్ అయింది. కార్బన్ కి 2 హైడ్రోజన్ అటమ్స్, నెక్స్ట్ కార్బన్ అటాచ్ అయింది. That you have to write in the decreasing atomic number. Sir, for example, for this one carbon, 2 hydrogen atoms, carbon, hydrogen. Then here, fluorine, carbon, hydrogen. Sir, of course, first atom, next atom, that means ఈ కార్బన్ తర్వాత వచ్చే నెక్స్ట్ ఆటం, ఈ కార్బన్ తర్వాత వచ్చే నెక్స్ట్ ఆటం. సో ఇక్కడ కార్బన్ ఉంది, దెన్ ఇక్కడ ఫ్లోరిన్ ఉంది. ఫ్లోరిన్ ఇస్ ద హయ్యర్ ప్రియారిటీ, యూ హ్యావ్ టు గివ్ ద. So like that. Are you getting my point? Yes, my dear students. In case first atom యొక్క atomic number, mass number same అయినప్పుడు you have to go for the next atom. Next atom కూడా same అయితే next atom. So you have to take like that. So for example, so last and the third rule itself, one more example, very, very important. Third rule. Sir, example number 3, that is CHCl CH3. Then one more CHCl CH2I, like this will be there. Yes, look at my dear students. Sir, C double bond C, a double bonded carbon atom contains one is CHCl CH3. Sir, one more CHCl CH2I will be there like this. So ఇప్పుడు ఫస్ట్ ఆటం చూడమన్నాను. ఫస్ట్ రెండిటికిను కార్బన్ ఆటం ఉంది. సో కార్బన్ ఆటం కూడా. నెక్స్ట్ ఆటమ్స్ ఏమున్నాయి? సో నెక్స్ట్ ఆటం హైడ్రోజన్, కార్బన్, క్లోరిన్. క్లోరిన్ ఇస్ ద హైయర్ అటామిక్ నంబర్, దెన్ ఆఫ్టర్ కార్బన్, దెన్ ఆఫ్టర్ హైడ్రోజన్. ఇందులో సేమ్, ఇందులో కూడా క్లోరిన్, దెన్ కార్బన్, హైడ్రోజన్. సో ఇక్కడ కూడా 3 ఆటమ్స్ ఉన్నప్పుడు యూ హ్యావ్ టు గో ఫర్ ద నెక్స్ట్ కార్బన్. నెక్స్ట్ దేనికి అటాచ్ అయింది? సరే ఈ కార్బన్కి అటాచ్ అయింది. సరే ఏమేమి అటాచ్ అయినాయి? హైడ్రోజన్, హైడ్రోజన్, హైడ్రోజన్. Then what about this? So for this carbon, iodine, hydrogen, hydrogen. Iodine, hydrogen, hydrogen. So you have to take, this is the higher priority, right? So that's what I told, this is the higher priority. Understand, my dear students? So this is the higher priority. Then this is the lower priority. Lower priority. So look at this chlorine, this bromine is attached. Chlorine and bromine, which is the higher priority? This is the higher priority. So is that higher priority or opposite side is there? E isomer. E isomer. Understand, my dear students? Yes. Then rule number 4. So rule number 4. Rule number 4. If multiple bonds containing groups attached to carbon atom. So like this, for example, CHO, we can call it as C double bond OH, right? Sir, when double bond is there, you have to observe that that particular carbon atom containing 2 oxygen atoms, 1 hydrogen, like this. So double bond in equivalent to 2 oxygen atoms you have to take. So ఇప్పుడు ఈ కార్బన్ కి ఏమేమి అటాచ్ అయినాయంటే ఆక్సిజన్, ఆక్సిజన్, హైడ్రోజన్, like this. Sir, in case C triple bond N is there, then you have to consider that C attached with nitrogen, nitrogen, nitrogen. Clear, my dear students? So ఏం అటాచ్ అయింది ఆ కార్బన్ కి నెక్స్ట్ ఆటం? నైట్రోజన్, నైట్రోజన్, నైట్రోజన్. Sir, in case COOH is there, COOH, that we can also write like this, C double bond OOH, right? So when C double bond O is there, means CO, then OH, like this. So OOH, sorry, OOO, you have to take. So OOO, you have to take. So these are the atoms. This is the last rule in the CIP rules. So look at, for this one of the example I will give to you. Sir, in case C double bond C is there, sir, one is CHO is there, then here C triple bond N is there. Sir, here carbon, carbon, same atoms. Next atoms, what you have to take in the CHO, I told, OOH, OOH. Then here N. Sir, which is the higher atomic number in the next atom? Oxygen and nitrogen, which is the higher atomic number? Oxygen. So this is the higher priority, this is the lower priority. Understand, my dear students? In case here bromine is attached to there, then chlorine is attached to there. Bromine is the higher priority, then chlorine is the lower priority. So higher priority, same side will be there, then we call it as Z isomer. Okay, right. So now based on these rules, I will give some of the examples. Then you have to understand that which is Z isomer, which is E isomer. Look at. Look at, my dear students, is that understand? I think so. For you people, in case if it is not understand to you, sir, please comment in the comment section. It is not understand to me like that, right? Sir, for example number 1, C double bond C, then CHO, CH2OH, then Cl, then Br is there. So number 2, C double bond C, Cn, then CH2OH, then H, then Cl, like this will be there. Third one, C double bond C, then one is CH3, then one more CH2OH, then CH2Cl, then CH2Br, like this will be there. See, my dear students, in these, which is cis isomer, which is Z isomer, which is E isomer, that you have to identify. Sir, first chlorine and bromine, in case if you take, this is the bromine is the higher atomic number according to the rules. Sir, here CHO is there. I told that C double bond OH. So next atoms మనం ఈక్వలెంట్ ఆటమ్స్ ఎలా తీసుకోవాలని చెప్పాను, O, then H. అంటే ఏమేమి తీసుకుంటాం, OOH. సో ఇక్కడ OOH వస్తాయి నెక్స్ట్ ఆటమ్స్. ఇక్కడ కార్బన్ ఆటమ్ తర్వాత నెక్స్ట్ ఏమేమి అటాచ్ అయినాయి, హైడ్రోజన్, ఆక్సిజన్, హైడ్రోజన్, హైడ్రోజన్. సరే, ఇప్పుడు ఫస్ట్ ఆటమ్ ఆక్సిజన్, then next atom oxygen, hydrogen. So which is the higher priority? This is the higher priority. So you have to consider this is the higher priority. Then sir, higher priority. So higher priority, same side will be there, we call it is Z isomer. Next, for this chlorine and hydrogen, of course chlorine is the higher priority atomic number according to atomic number. Here carbon attached same. Then next atoms you have to take, when Cn is there, nitrogen, next atoms 3. Then here oxygen, hydrogen. So oxygen is the higher priority, you have to take like this. Oxygen is the higher priority. Understand, my dear students, right? Then go for, sir, here carbon, next atoms are hydrogen. Then here oxygen, hydrogen. Sir, which is the higher priority? This is the higher priority, right? Sir, here this is the higher priority. I told when higher priority groups are away from each other, then E isomer. Then what about this? Then here a carbon is same. Then of course next atoms chlorine, hydrogen. Then bromine, hydrogen. So chlorine and bromine is the higher priority. So this is the higher priority of the group. Then this is, so even this is also E isomer. Yes, understand, my dear students? I hope it is understand to you what is E and what is Z isomer. So these can exhibit E and Z isomerism. So according to the priority order can be explained by which rules? CIP rules. CIP nothing but chain in gold prologue rules. So according to the rules, you have to identify which is the higher priority, which is the lower priority. Higher priority groups are same side will be there, then we call it as Z isomer. Higher priority groups are opposite side will be there, then we call it as trans isomer. Next, sir, one more third type it is in the geometrical isomerism, Syn-Anti. syn and anti isomerism. When it can exhibit syn and anti isomerism? Sir, in the oximes. Sir, what are those? Oximes and azo compounds. Azo compounds, we can observe that azo compounds and oximes we can exhibit, which is syn and anti. Sir, what is the oxime generally? Sir, aldehyde gani, aldehyde or ketone. For example, aldehyde I am taking CH3, then C double bond OH, like this will be there. When it is treated with hydroxylamine, NH2OH, like this. So now, after the removal of water molecule, when both are reacting by the loss of water molecule, C double bond N, then OH, CH3, then H. So this we call oximes. ఏమంటుంది oximes. Sir, ఇందులో H with respect to HOH. Sir, C double bond N, both are restricted rotation. ఒక lone pair of electrons ఉంటుంది, ఒక OH ఉంటుంది. Then what will be there? H, then CH3, like this will be there. All oximes we call. Sir, HOH same side ఉంటే, then we call it is Syn-isomer. Syn-isomer. The same thing, C double bond C, N, then lone pair of electrons are there here, then OH is there, then CH3 is there, then H opposite side lo unte, HOH opposite side lo unte, then anti-isomer. Anti-isomer, like this. So even then C double bond C, then in case C2H5 is there, then C double bond N, right? C double bond N, then OH, then lone pair of electrons are attached to there, then H is there. Sir, even it is also aldoxine. Then HOH ఒకే side లో ఉంటే syn అని, then HOH opposite side లో ఉంటే C2H5 opposite side lo unte anti, we call it as anti-isomer. Understand, my dear students? So in the oximes you can observe that syn-anti. Even in the azo compounds also, azo compounds nothing but N double bond N should be present. N double bond N should be present. Sir, oxime means C double bond N. Azo means N double bond N. Sir, azo compounds if you take, for example, N double bond N is there. One lone pair of electrons are there. Sir, in case here phenyl group, then one more lone pair of electrons we are taking. Then here phenyl group is there. Phenyl group is there. Then electron density, based on the electron density, if electron density opposite side is there, opposite side, then we call it as anti. Sir, N double bond N. So look at, sir, here lone pair of electrons, even here lone pair of electrons will be there. The phenyl group is attached to there. Even here also phenyl group is attached to there. Then we call it as syn-isomer. So it can exhibit syn and trans-isomer. So my dear students, you have to remember, so carbon double bond also exhibit, carbon double bond nitrogen also can exhibit, nitrogen double bond nitrogen also can exhibit. So these are cis trans, then Z, syn, anti, all geometrical isomerisms we are seen in this. So in the next chapter we'll discuss the same geometrical isomerisms in the cyclic compounds, how it can be exhibited, spiro compounds, and the number of multiple bonds are present in the given compound. How geometrical isomerism can exhibit, that we'll discuss. Thank you. We'll go for the next video.